Welcome to A-Level and EP Physics. In today's lesson, we will discuss one very nice question on gravitational field from May June 2022, paper 4, variant 2. In this question, we will discuss some very important points about this topic. We will talk about how we can define gravitational potential at a point. We will also discuss how we can derive formula for gravitational potential energy using concept of gravitational potential. Then we will talk about how to calculate change in gravitational potential energy and also change in kinetic energy. Then we will discuss what is the relationship between work done by gravitational force and change in gravitational potential energy. And some other points we will also discuss in today's lesson. So in today's lesson, we are going to discuss very important points about gravitational field. And understanding of this question will help you to understand this topic. Let's study together. Let's improve together. For question number 1, part A1, we need to define gravitational potential at a point. And this question is very common in past papers. Why this question is so common in past papers? Because this concept is very important to understand gravity and gravitational field. That's the reason this question is most frequently asked question in past papers. But let me tell you, in physics, gravitational potential or electrical potential is not defined. When we define gravitational potential or electrical potential, actually we are talking about gravitational potential difference because we use a reference point. So that's the reason gravitational potential is not defined, and also electrical potential is not defined in physics. When we define them, we take a reference point. So we talk about gravitational potential difference, or we can say we talk about electrical potential difference. Now let me explain to you how we can use concept of gravitational potential difference to define potential at a point. So we will take one point as a reference point, and that point will be infinity. First of all, imagine that we have a mass. This is capital M. It has its own gravitational field around itself. So this is the gravitational field. You need to understand gravitational force is always attractive force. So these arrows should be pointing towards this mass. So this is the gravitational field around this mass. Now imagine that we need to find out potential at any single point. Let's say we want to find out potential at this point. Let's say I want you to find potential at point P. If you need to find the potential at point P, you need to go to infinity. Imagine that at infinity. So this is infinity. At infinity, we define potential is equal to 0. Now you need to take one unit mass from this point, means from infinity, and at infinity, kinetic energy of this unit mass is equal to 0. Now you have to move this one and you need to bring this one to this point. Mean you take this unit mass from infinity and you have to bring this one to this point. And when you bring this one to point P, its kinetic energy also has to be 0. It simply means that you have to move this mass very slowly. In order to move this mass very slowly, you have to do work against gravity. So it simply means that if we look at this point, you have to apply force this way. So we can say this is external force, and this force has to be almost equal to very little difference between two forces, means the force of gravity and external force. So slowly you move this one from infinity to point P. So the amount of work done by you, if we divide that one by unit mass, that is gravitational potential at this point. Actually, that is gravitational potential difference because our reference point is infinity. But this is how you can define gravitational potential at a point. So simply in this case, you will say gravitational potential at point P is equal to the work done to bring unit mass from infinity to point P divided by mass means the unit mass. And in this case, you need to understand work done by external force is negative. So that's the reason potential anywhere means after infinity is always negative. So the formula for gravitational potential at any point we have, that is G capital M divided by R, means R is the distance from the center of this mass to point P. So this is how we define gravitational potential. So you need to understand how we define. So let me show you the answer, how you can write down the answer. This is how you can write down the answer. This question has 2 marks. If you have written work done per unit mass, you will get 1 mark. And if you have mentioned to bring unit mass from infinity to that point, you will get the 2nd mark. So you will get 1 B mark here and 2nd B mark here. So this is how these 2 marks will be awarded. I hope your concept of gravitational potential is now clear. How we define gravitational potential at a point. And also you need to understand potential is a scalar quantity. So this is a scalar quantity. For the second part, we need to start from the equation of gravitational potential due to a point mass, and we need to show that gravitational potential energy EP of a point mass small m at a distance small r from another point mass m is given by this equation, and G is the gravitational constant. So first of all, imagine that we have one point mass, and mass of this point mass is capital M, and it has its own gravitational field around it. So simply we can draw this one is the gravitational field. So this is gravitational field around this point mass. Now question is asking us, first of all, we consider potential at this point. Let's say this is point A. So the potential at this point due to this capital M, potential will be equal to minus capital G capital M, and R is the distance from this point mass to this point. So R is the distance. So we can also write down, in this case, R is the distance from the point mass. So this is R. R is the distance. Now we bring another mass, small m, and we place at this point. Now question is asking us to calculate the gravitational potential energy of small m. So the gravitational potential energy, first of all, we need to understand this is equal to mass in the gravitational field times the potential at that point due to other mass, means the heavier mass. So this is the product of potential times the mass. The mass we bring in the gravitational field of another mass. So now simply we need to replace this potential with this one. So we can write down this is minus capital G capital M divided by R multiplied by small m. So that's all what you need to do for this question. Then if you write down these 2 steps, you will get 1 mark, and that is B mark. So this is how this B mark will be awarded. For part B1, we need to calculate the magnitude of the change in gravitational potential energy of the comet as it moves from position X to position Y. Means when comet moves from this point to this point, what is change in gravitational potential energy? So first of all, we can label the mass of the comet small m, and the mass of the star we can label this one is equal to capital M. And we can also label the distance of this comet from the center of this star. Let's say this distance is equal to Rx. We can say this distance is Rx, and the distance of the comet from the center of the star at this point, let's say this distance is Ry. So we can label this is Ry. And now we can use our understanding of gravitational potential and gravitational potential energy to calculate the change in gravitational potential energy. Before we answer this question, one thing you need to understand is that as this comet is getting closer to this one, kinetic energy of the comet will increase, but gravitational potential energy of this comet will decrease. So when we will calculate in this case the change in gravitational potential energy, our answer has to be negative. So let's try to answer this question now. First of all, we need to understand, we need to calculate gravitational potential energy, change in gravitational potential energy. So we will take final gravitational potential energy at point y minus gravitational potential energy at point x. Now we can write down this potential energy in terms of potential. So for potential energy at point y, we can write down this is potential at point y minus we have gravitational potential at point x, and we have to multiply this one with mass of comet. Now we can write down potential at point y, that will be equal to negative gm, means the mass of the star, divided by distance from the center of the star, ry, minus, and we have also minus sign here because potential is negative, divided by rx. Multiply this by mass of comet. Now we can further simplify this. We can write down this is negative gm over ry, and this one we have plus g capital M divided by r sub x, and this is multiplied by m. Now in this case you can see we have gm, we can take this common, so we have g capital M small m. It is already out of the bracket, so we can write down this one simply in terms of rx and ry because we have taken gm common. So we can write down this is 1 over r sub x minus we have 1 over r sub y. We need to plug in values. That's all what we need to do now. In this case, value of G we have that is equal to 6.67 times 10 to negative 11, and this one has to be multiplied with mass of the star, and mass of the star is given here. So this is mass of the star, that is equal to 1.99 times 10 to 30 kgs, and small m is mass of comet, and this is mass of comet. Mass of comet is 2.20 times 10 to 14, and we have to multiply this one with 1 over rx. Rx is the distance of the comet when it is at point x. At point x the distance is given, that is equal to 8.44 times 10 to 11 minus when the comet is at point y, means the distance between center of the star and center of comet when comet is at point y. At point y distance is also given to us, so here this is the distance. So we have this is 6.38 times 10 to 10. Now you just need to use a calculator. Put all the numbers in your calculators, but be careful with the signs and you will get your final answer. Final answer in this case will be equal to 4.23 times 10 to 23 joules. But your answer will be negative. And negative simply tells us that gravitational potential energy of the comet is decreasing when it is moving from point X to point Y. So that's all what we need to do for this question. And for this question, if you have written this step, you will get 1 mark, that is C mark. And the second mark is answer mark if you have got the right answer. This is how marks will be awarded. Always approach gravitational potential energy using concept of potential. Very important tool to answer this type of problems. For the second part, we need to state with a reason whether the change in gravitational potential energy in B1 is an increase or a decrease. We have already discussed in part 1 that energy decreases. So we can simply state gravitational potential energy decreases. Now we need to explain a reason. In order to explain a reason, we need to understand change in gravitational potential energy and how this is linked with work done by gravitational force. Change in gravitational potential energy is equal to negative of work done by gravity, or simply I can say by any attractive force. So that is also true for electrical force when electrical force is attractive. So simply we can say for attractive force. If the work done by attractive force is positive, it means the change in gravitational potential energy will be negative, and vice versa is also true. So simply we can say if work done is positive, so we can write down 2 points here. Change in gravitational potential energy is positive if work done is negative. If work done is negative, simply we can say delta U will be positive, and delta U will be negative if work done is positive. that in this case work done is positive, means gravitational force is doing positive work, so the gravitational potential energy is negative. So simply we can say, as in this case work is done by gravitational force, so the change in gravitational potential energy is negative, or simply you can say gravitational force is attractive, so gravitational potential energy decreases. You can write down any 1 point and you will get 1 mark. This question has only 1 mark. Let me show you how you can write down your answer. This is how you can write down your answer. You can say gravitational force in this case is doing positive work, so GPE decreases. And this question has only 1 mark. If you write down this point, you will get 1 mark. Now simply you can say, as gravitational force is an attractive force, so GPE decreases. You will also get 1 mark. Means still you will get 1 mark. If you write down the first one or the second reasoning, you will get 1 mark. Very important point. You need to understand. If work done by attractive force is positive, change in GPE or change in potential energy will be negative. If work done by attractive force is negative, change in potential energy will be positive. You can also imagine that this one, let's say I have this small box. If I raise this one, in this case work done by gravity is negative, so the potential energy increases. But if I lower this one, means if I drop this one, work done by gravitational force will be in this case positive, so its gravitational potential energy will decrease. Very simple concept, but most of the time many students, they're not clear about this one. Concept is very simple. If the work done by gravity, if I raise this one, work done by gravity is negative, so the gravitational potential energy of this box will increase. But if I drop this one, in this case work done by gravitational force is positive and its gravitational potential energy will decrease. And this is what is happening in case of comet and star. So gravity is pulling this comet, so work done by gravity is positive and gravitational potential energy of this comet is decreasing. For our third part, we need to use our answer in B1 to determine the speed in kilometers per second of the comet at point Y. So this is hint, means we need to use our answer from B1. In B1 we have calculated change in gravitational potential energy, and in this system there is only one force, that is gravity. So it simply means that in this case mechanical energy of this system is conserved. So we can simply say loss in GPE is equal to gain in KE, and loss in GPE means the change in gravitational potential energy we have already calculated, that was equal to 4.23 times 10 to 23. Now we need to calculate change in kinetic energy, and then we can find out the speed of this comet at point Y, means at this point Y. We can find out speed of comet. And let's say this speed at point X is Vx, and the speed at point Y, let's say this is Vy. And we need to calculate in this case Vy. So we can write down the formula for change in kinetic energy. In kinetic energy, mass is common, so we can take out. So we can write down speed of the comet at point Y minus speed of the comet at point X. Now we can plug in values for mass. Mass of the comet is 2.20 times 10 to 14 times we need to calculate Vy. So simply we can write down Vy square minus Vx. Vx is given to us here, so this is value of Vx, but we have to use meters in this case first of all. So we have to multiply this one with 1000 and square of this one, square of this. And now we can solve this one for the value of Vy, value of Vy. If we solve this one for the value of Vy, our final answer in this case has to be equal to 70.8 kilometers per second up to 3 SF. So this is our final answer. Simply you need to understand for this question, mechanical energy is conserved. So the change in gravitational potential energy is equal to change in KE. And simply you need to equate and you can find value of Vy. And your answer has to be in kilometers per second. This question has 3 marks. The first mark you will get if you have written this step. You will get 1 C mark. And the second C mark you will get if you have sub these values. And the third mark is the answer mark. If you have got right answer, you will get 3 marks. So this is how marks will be awarded for this part of the question. For part C, it is given to us a second comet passes point X with the same speed as the comet in B. Traveling in the same direction, this comet is gradually losing mass. The mass of this comet when it passes point X is the same as the mass of the comet in B. Suggest with a reason how the path of the second comet compares with the path shown in figure 1.1. A bit tricky question. Let's try to understand this one step by step. First of all, imagine that we have one mass capital M. You can imagine that this is our planet. You can imagine this is Earth. And there is a satellite or any other object that is orbiting around this heavier mass. So this one you can imagine is satellite or any other object. Now, if we try to calculate the orbital speed of this one, we need to equate centripetal force with gravitational force. Mean in this case, orbital radius, first of all, let's say this is capital R. This is orbital radius, not radius of this heavier mass. So in this case, centripetal force will be provided by the gravitational force between these two objects. So here we will have R squared. Now we can cancel this M with this M, and we can cancel this R with this. So we will get V in this case, V will be equal to G capital M over R. And this V is the orbital speed. So this V is orbital speed. Now from here we can see that orbital speed does not depend on mass of satellite, or it does not depend on mass of object in orbit. If I replace, let's say, this satellite with an other satellite, and mass of that satellite, let's say, is equal to m1. So you will see m1 again will be cancelled. So the first thing you need to understand in this case, orbital speed does not depend on mass of orbiting object. It only depends on mass of this heavier object, and it depends on orbital distance, or simply you can say orbital radius. It is depending on these two. It is simply depending on mass of this heavier object, and it is depending on orbital distance, or you can say orbital radius. Let's try to answer this question using concept of energy. Before we use concept of energy, we need to understand this comet is made of many small pieces. Means we need to imagine that it is made of many small pieces. So this is comet. You can imagine that this is made of many small masses, and on the way from X to Y, this comet is losing mass. Now if you look at orbit of any one mass, we will see that change in gravitational potential energy, this is equal to change in kinetic energy. And in this case, change in gravitational potential energy is equal to m times delta phi, and the change in kinetic energy is equal to v square minus u square. So mass is on both sides, so mass will be cancelled. So each piece of comet will follow the same orbit. So this is what you need to understand for this question. And for the sake of answer of this question, simply this is how you can write down your answer. Let me clean this one so you can see what I have written. So simply you can say, as both potential energy and kinetic energy equations, they include m, so the path is unchanged. The main concept is you need to visualize it is made of small pieces, and it is losing some of the pieces, and the orbital speed of any mass is independent of the mass of the piece itself. So that's the reason it will follow the same orbit. I hope this is clear to you. If you have any questions, leave your questions in comments. And we have finished Module 2022 paper 4.2. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one important past paper question on electric field and PET. In this question, we will talk about electric field, we will discuss Coulomb's law, we will also talk about circular motion. At the end of this lesson, we will also talk about little bit about PET. So this is a great question on all these topics. Watch the video carefully and try to improve your understanding of these topics. Let's study together, let's improve together. For question number 2, part A, we need to state Coulomb's law. Imagine that we have 2-point charges. Let's say this charge is plus Q and we have another charge plus Q. This is also point charge. Point charge simply means that the size of the charge is very small as compared with the distance between charges. So we can treat these charges as point charges. And now imagine that the distance between these two charges means the distance from center to center. This distance is r. Coulomb's law simply tells us the force between these 2-point charges is directly proportional to the product of these charges. We can say, let's say this is charge Q1 and this is charge Q2. So the force between these two charges in this case will be repulsive force. That force is directly proportional to the product of these two charges. And this force is inversely proportional to the square of separation between them, means inversely proportional to the square of distance between centers of these charges. So this is what Coulomb's law tells us, and this is what is Coulomb's law. We can also write down this one in equation form. We can simply write down F is equal to constant of proportionality Q1 Q2 divided by R square. Here K is equal to 1 over 4 pi epsilon naught. So this is K, and it is multiplied with Q1 Q2 divided by square of distance between the centers. So this is how Coulomb's law can be stated. Now let me show you the answer, how you can write down your answer. This is how you can write down your answer, and in your answer, if you have mentioned electric force between 2-point charges is directly proportional to the product of the charges, you have to mention 2-point charges. This is very important point. And inversely proportional to the square of the separation. You will get 2 marks. First one has 1 mark, this is B mark, and the second point also has 1 mark, that is also B mark. So this is how marks will be awarded, and this is how you can state Coulomb's law. Very similar to Newton's law of gravitation. So Newton's law of gravitation and Coulomb's law, they're very similar. In Newton's law of gravitation, we talk about point masses, and in Coulomb's law, we simply talk about point charges. Everything else is the same. In Coulomb's law, we talk about point charges. In Newton's law of gravitation, we talk about point masses. In Newton's law of gravitation, you also need to understand, means if you're talking about gravitational force, we have capital G. This is universal gravitational constant, and here is Coulomb's constant. So that is also the difference. So we have G m1 m2 divided by r squared. So this is Newton's law of gravitation, and here we have Coulomb's law. So this equation is for Coulomb's law. You can see only difference is K, G, and here we have point charges, and here we have point masses. For part B, it is given to us positronium is a system in which an electron and a positron orbit with the same speed about a common center of mass, as shown in figure 2.1. The radius r of the orbit of both particles is 1.59 times 10 to minus 10 meters. For part B1, we need to explain how the electric force between the electron and the positron causes the path of the moving particles to be circular. So simply we need to explain why these particles are moving in circle, or simply we can say why they are doing circular motion. So this is what we need to explain. If you look at these particles and we look at the forces between them, electron is negatively charged and positron is positively charged. And the force between them, so there is a force on electron due to positron, and that force is directly to the right, and there is also force on positron, then that force is directed to the left. Then these two forces are equal in magnitude. If we draw electron at this point, when electron is here, positron will be here, because they have the same speed. So we can draw forces again on these particles. So this is the force acting on electron. There will be force acting on positron in opposite direction. So this is how forces will be acting. We can draw this one at any point. Imagine that when electron is here, positron will be somewhere here. So there will be force on electron along this line, and there will be force on positron along this line. Now, if you look at velocity, this is moving clockwise. So you can see the arrow. So these particles are moving in clockwise direction. So if you look at this particle, when it is at this point, velocity of this particle is directed vertically downwards. And velocity of this one will be directed vertically upwards. Now, if you look at the angle between force and the velocity, this angle is 90 degrees. So simply we can say force in this case is perpendicular to velocity. And force between these two particles is constant because force, Coulomb's force is equal to K Q1 Q2 divided by R square. Force is constant. So second point we can write down, force is constant. Force is constant, means force on each particle is constant, and force is perpendicular to velocity. We can also write down in this case, centripetal force is provided by electric force. Centripetal force is provided by electrical force. And electrical force is constant, so it means centripetal force is also constant. And these are the conditions for uniform circular motion. So that's the reason these particles, they will move in circle, or they will do circular motion. And these points only we need to write down to answer this question. This question has 2 marks. If you write down these 2 points, you will get 2 marks. Let me show you the answer. You can also consider this point. For example, at this point you will see the velocity will be directed this way. Again, angle is 90 degrees. At any point, you can also draw at this point. So this is V, and in this case you will have V here. So these are basic conditions for uniform circular motion. Force has to be constant and force has to be perpendicular to velocity. Then body will move in a circle with constant speed and centripetal acceleration. This is how you can write down your answer. In your answer, you need to write down electric force is perpendicular to velocity and it will cause centripetal acceleration. You will get 1 mark, and that mark is B mark. And the second mark you will get, if you have written force has constant magnitude, you will get second B mark. This is how marks will be awarded. This question is very common. Sometimes they will only ask you about masses, or they will say one object is moving in a circle, explain why this is moving in a circle. So you can again write down these 2 points. For the second part, we need to show that the magnitude of electric force between electron and positron is equal to this. So we need to calculate magnitude of force. In order to calculate magnitude of force, we need to use Coulomb's law equation. Means F is equal to 1 over 4 pi epsilon naught times Q1 Q2 divided by R squared. So we need to calculate force. In this case, the charge on electron and charge on positron is the same. Charge on electron because they are particle and antiparticle. Particle and antiparticle, they have the same amount of charge but opposite. So the charge on electron is equal to charge on positron. And charge on these 2 particles is equal to 1.6 times 10 to negative 19 coulomb. So this is value of Q. Now simply we need to plug in values. In this case we have 1 over 4 pi epsilon naught. Epsilon naught has value 8.85 times 10 to minus 12. So this is value of epsilon. And you can get this value from given data, means from constants. Q in this case is 1.6 times 10 to negative 19. This is the amount of charge on electron, and amount of charge on Positron also is the same. We are just talking about magnitude, so we can just plug in value of magnitude. And the separation between these two charges is given. Separation is 1.59. The radius of orbit of the particles is given. But you need to understand, in this case, we need separation between charges. So separation between centers of these two charges is equal to 2r. So this is value of 1r, but the separation is equal to 2r. So we have to multiply by, so this is 10 to minus 10. So we have to multiply by 2. And we need to take square of this. Now, if we solve this one, our final answer has to be equal to 2.28 times 10 to minus 9 newtons up to 3 SF. So this is our final answer. And this question has 2 marks. The first mark you will get if you have written this equation. You will get 1 C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. If you have written this equation, you will get 1 C mark. So this is how marks will be awarded for this question. One thing you need to understand in this case, charge on these two particles is the same because they are particle and antiparticle. And the second confusing part is you need to consider separation between these two charges, not only radius. For third part, we need to use information in B2 to determine the period of the circular orbit of two particles. We need to determine the period. These two particles, they have the same period and they also have the same speed. So we need to calculate time period. In order to calculate time period, we need to consider the circular motion, meaning we need to consider centripetal force. In this case, centripetal force is provided by electric force. So you can write down first point, centripetal force is provided by electric force. Centripetal force, we need to understand, is equal to mv squared by r. In this case, we need to calculate time period, so we can rearrange this one. We need to understand the speed of the particle, in this case, will be equal to 2 pi r divided by time period. So this is the orbital speed of any single particle. And these two particles, they have the same orbital speed. Now we can plug in value of v here. We can write down this is m over r. Then here we have this is 2 pi r divided by t. And this is square. We can simplify this. We can write down m times 4 pi square times r square divided by, we have this is t square, and this is equal to centripetal force. We have r here, so we can cancel this r with this. We need to calculate time period in this case, so it means t will be equal to 4 pi square times r times m. So we have m, and this will be divided by f. Now if we take square root of this one, we can calculate value of time period. Now simply we need to plug in these values and we can calculate time period. 4 pi, so we have 4 pi square, and the radius of this orbit is 1.59 times 10 to minus 10, and mass of the particle, these are particle and antiparticle. Particle and antiparticle, they have the same mass but opposite charge. So it means we need to consider mass of electron, and mass of electron is equal to 9.11 times 10 to negative 31 kgs. So the mass is 9.11 times 10 to negative 31 kgs. And we need to divide this one by Coulomb's force, meaning the electric force between these two charges. Electric force we have already calculated, that was equal to 2.28 times 10 to minus 9. And the power of this one is 1 by 2. If we simply put these numbers into calculator, we can calculate value of time period. In this case, time period will be equal to 1.58 times 10 to minus 15 seconds. Very fast. It means electron and positron, they will be moving very fast. You can see time period is very short. So it means they're moving at very high speeds. So this is how we can calculate time period. So our final answer for this question is 1.58 times 10 to minus 15 seconds. Our answer is up to 3 SF because here we have 3 SF, we have 3 SF, we have 3 SF. So in our final answer, we need to consider least number of SF. Our data has least number of SF 3, so our final answer is also up to 3 SF. So this is our final answer. This question has 3 marks. The first mark you will get if you have written this formula. If you have written this formula, you will get 1 C mark. So you will get 1 C mark. And the second mark you will get if you have plugged in values of time period, means values for these quantities for time period. You get 1 C mark. And you will get another mark. This is answer mark if you got the right answer. If you got right answer, you will get 3 marks. For part C, it is given to us positronium is highly unstable. After a very short period of time, it becomes gamma radiation. For part C1, we need to describe how gamma radiation is formed from the 2 particles in positronium. First thing we need to understand, we are talking about electron and positron. So simply I can write out here. So this is electron and this one is positron. Electron is particle and positron is antiparticle. So this one is antiparticle of electron. So simply we can write down this one is antiparticle. Particle, we can also say this is matter. And antiparticle, we can also say this is antimatter. When matter and antimatter, they interact. Let's say we have electron. When this electron, it will interact with positron. With positron, they will annihilate. And in this case, mass will be converted into energy. So 2 gamma radiation will be emitted. So in this case, mass will be converted into energy. When mass is converted into energy, this process is called annihilation. Mass is converted into energy. This process is called annihilation. Means these particles, they will be annihilated and the mass will be converted into energy. This process is called annihilation. But if energy is converted into matter, that process is called creation, like the creation of the universe. So that is called creation. If the energy is converted into mass, that is creation. But if mass is converted into energy, that is called annihilation. In this case, annihilation will take place and electron and positron, they will disappear. They will be converted into energy. Simply we can say, in this case, electron and positron, if they interact, they meet, the mass will be converted into energy. Particles will disappear and energy will appear. This is what we need to write down for the answer of this question. So let me show you how you can write down the answer. In your answer, you can mention these points. You can say positron is antiparticle of electrons as positron interacts with electron. Here, annihilation occurs and the mass is converted into photon energy, mean in form of gamma radiations. In this case, 2 gamma radiations will be emitted to conserve momentum. For the second part, we need to state one medical application of the process described in C1. And this process is used in PET, positron emission tomography, PET. So this is one application of this process. This question, the first question has 3 marks. So you will get 1 mark for writing this point. And for the second one, you will get this second point, and for the last one you will get the 3rd mark. And for this question, only 1 mark, you will get 1 P mark if you have written PET. So this is how marks will be awarded for this question. I hope this question is clear to you. We have solved from question 2 to question 10, means we have discussed 9 questions from May June 2022 paper 4.2. Only 1 question is left and that question will be coming very soon. For rest of the question from question number 2 to question number 10, you can find solution of all the questions on my channel. And if you have any questions, feel free to ask anytime. And also you can ask any questions about any past paper. That's all for today's video. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss one important past paper question on thermodynamics from June 2022, paper 4, variant 2. In this question, we will talk about specific latent heat of vaporization. We will discuss how we can define specific latent heat of vaporization in a right way. Then we will talk about first law of thermodynamics and applications of first law of thermodynamics in different situations. So we will discuss some important points about thermodynamics in today's lesson. Watch the video carefully and try to improve your understanding of this topic. In order to get maximum benefit from these lessons or from these videos, always pause the video, do questions by yourself, and then compare solution with my solutions. Let's study together, let's improve together. For part A, we need to define specific latent heat of vaporization. First of all, let's try to understand what is meant by specific. Specific simply refers to unit mass. Means when we say specific, it simply means that we are talking about unit mass. And vaporization means that liquid changes into gas. So these two key words we need to understand before we answer this question. So simply we can imagine, first of all, we have unit mass of liquid. So we have unit mass of liquid. Unit mass simply means that we are talking about 1 kg. And here we have liquid. We have unit mass of any liquid. And we convert this unit mass of liquid into unit mass of gas. Unit mass. So here we have unit mass of gas. So simply we can say unit mass. Unit mass again means 1 kg. Now imagine that this liquid has a boiling point. Its boiling point is 100 degrees Celsius. And we convert this one into gas, and gas is also at 100 degrees Celsius. So we convert this liquid into gas. In this case, temperature is not changing. So you can see delta T in this case is equal to 0. But we have to supply heat. So in this case, the potential energy of the gas will increase. So the potential energy is increasing. So we have to supply thermal energy. But kinetic energy is not changing. So we have to supply certain amount of thermal energy. Thermal energy. In this case, kinetic energy of molecules is not changing, but the potential energy of molecules is changing. Or simply you can say we have to supply thermal energy to break the bonds. And this thermal energy is called specific latent heat of vaporization. Specific latent heat of vaporization. So this is how we can define specific latent heat of vaporization. So simply we can say vaporization. Now let me show you the answer, how you can write down a proper answer. So this is how you can write down your answer. Simply you can say thermal energy per unit mass required to change state between liquid and gas at constant temperature. Means temperature of liquid and gas is the same. So this is how you can define. This question has 2 marks. If you have written thermal energy per unit mass, you will get 1 B mark. And the second B mark you will get if you have written required to change state between liquid and gas at constant temperature. You will get second B mark. So this is how marks will be awarded. For part B, it is given to us the specific latent heat of vaporization of water at atmospheric pressure of 1.0 times 10 to 5 pascals is 2.3 times 10 to 6 joules per kg. A mass of 0.37 kgs of liquid water at 100 degrees Celsius is provided with the thermal energy needed to vaporize all the water at atmospheric pressure. We need to calculate thermal energy Q supplied to the water. So first of all, let's try to visualize this one. In this case, we have a liquid. So this liquid is at 100 degrees Celsius. So this is in liquid form. So this is liquid. And the mass of this one is given. M for this one is 0.37 kgs. And we convert this one into gas at 100 degrees Celsius. So gas is at 100 degrees Celsius as well. And in this case, specific latent heat is given, means L is given to us. L is equal to 2.3 times 10 to 6 joules per kg. It simply means that if we need to convert 1 kg of water into gas at 100 degrees Celsius, we have to supply 2.3 times 10 to 6 joules of thermal energy. But in this case, we have only 0.37 kilograms, so we need to calculate value of thermal energy supplied. So the Q is equal to simply M times L. M is equal to 0.37 kgs and L is equal to 2.3 times 10 to 6. Now, if we multiply this one, we will get 8.5 times 10 to 5 joules. So we have to supply this much thermal energy to convert 0.37 kilograms of liquid, means water, at 100 degrees Celsius to gas at 100 degrees Celsius. So our answer for this question is simply 8.5 times 10 to 5 joules. And this question has only 1 mark. If you have got the right answer, you will get this mark. For the second part, it is given to us the mass of 1 mole of water is 18 grams. Assume that water vapor can be considered to behave as an ideal gas. Means we can treat water vapor as an ideal gas. Very important assumption. Question is asking us to show that volume of water vapor produced is 0.64 meter cube. Or simply you can say cubic meters. For this question, first of all, let's try to sketch so we can visualize what is happening. We have liquid that is at 100 degrees Celsius. So simply we can say this one is liquid. And mass of liquid was given to us in part 1. Mass is equal to 0.37 kilograms, or we can simply convert this one into grams. So this will be equal to 370 grams because this mass is given in grams. It is converted into gas at 100 degrees Celsius. So these are water vapors. So now we will simply write on here water vapors. Water vapors. Mass of this one also is equal to 370 grams. Temperature is 100 degrees Celsius, but value of P is given. P is equal to 1.0 times 10 to 5 Pascal. We can assume water vapor as an ideal gas, means they behave as an ideal gas. So we can also write on here ideal gas. Water vapors behave as an ideal gas. For ideal gas, we need to understand PV is equal to nRT. For this question, we need to find out volume of water vapors. So we need to find out volume. So we can rearrange this. We can write down V is equal to nRT divided by P. For this question, we have value of T, we have value of P, but we don't have value of N. So first of all, let's try to find out value of N. N is equal to mass of water vapors. Mass of water vapors means the total mass. So we can say mass of water vapors divided by mass of 1 mole of water vapor. Mass of 1 mole of water vapors. Mass of 1 mole of water vapors. Total mass we have that is equal to 370 grams, and mass of 1 mole of water vapor is equal to 18 grams. So simply we have to divide this one by 18 grams. So N in this case is equal to 370 divided by 18. And we can plug in this value here now. So N we can replace with 370 divided by 18. And R is gas constant, and value of gas constant is 8.31. And temperature, it has to be in Kelvin. Temperature is 100 degrees Celsius. We have to convert this one into Kelvin. So we have 100 plus 273. So in this case, temperature is 373 Kelvin. So this is value of temperature. So we have 373 Kelvin. We need to divide this one by P. P in this case is 1.0 times 10 to 5 Pascal. If we solve this one, our answer in this case will be equal to 0.64 cubic meters up to 2 SF. And this is what question was asking us to calculate. This question has 3 marks. The first mark you will get if you have written this formula. You will get 1 mark. And the second mark you will get if you have written N is equal to 370 divided by 18. You will get second C mark. And the last mark you will get if you have got the right answer. So this is how marks will be awarded for this question. For our third part, we can assume that initial volume of the liquid water is negligible compared with volume of water vapor produced. Volume of water vapor produced we have already calculated in second part, and volume of water vapors was equal to 0.64 cubic meters. For this question, we need to determine the magnitude of the work done by the water in expanding against atmosphere when it vaporizes. So we need to calculate amount of work done. In order to calculate amount of work done by water, simply we need to use P times delta V. P in this case is constant, that is equal to atmospheric pressure 1.0 times 10 to 5. Change in volume, V final minus V initial. For this question, it is given to us V initial is equal to 0. Initial volume of water is negligible, so simply we can ignore Vi in this case. So again, we can write down 1.0 times 10 to 5. Final volume is equal to volume of water vapors, and initial volume means the volume of liquid water is negligible. So simply we can ignore that. Now, if we solve this one, our final answer will be equal to 6.4 times 10 to 4 joules. So this much work has to be done by water, and our final answer up to 2 SF is 6.4 times 10 to 4 joules. And this question has 2 marks. The first mark you will get if you have written this formula. This formula we only use when P is constant. So if you have written this formula, you will get 1 mark, that is C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part 4, we need to use answers in B1 and B3 to determine the increase in internal energy of water when it vaporizes at 100 degrees Celsius. And also we need to explain reasoning. Explain your reasoning, mean show your working. Let's try to answer this question step by step. In part B1, we have calculated thermal energy supplied. So we can simply write down thermal energy supplied. That was equal to 8.5 times 10 to 5 joules. We have already calculated this. In part B3, we have calculated work done by water. We can write down work done by water. Work done by water was equal to 6.4 times 10 to 4 joules. We can also convert this one into same power of 10. So we can write down this one 6.4 times 10 to 1 multiplied with 10 to minus 1 multiplied with 10 to 4. Now if we divide this one by 10, we can write down this is equal to 0.64 times 4 plus 1, 10 to 5. Q supplied and work done, they have the same power of 10. So it will make our calculations simpler. So this is one important step. We need to calculate change in internal energy. So simply we can say change in internal energy is equal to Q supplied. So you have to be clear. This is Q supplied plus work done on gas. In this case is water. So we will write down work done on water. But we have calculated work done by water. So we need to convert this one into work done on water. Work done on water will be equal to negative of work done by water. Work done by water. In this case, work done by water is equal to 0.64 times 10 to 5 joules. So this has to be negative. Now we can plug in values. Q supplied we have, that is equal to 8.5 times 10 to 5 minus 0.64 times 10 to 5. So we can calculate value of increasing internal energy. That one one will be equal to 7.9 times 10 to 5 joules. Our answer is positive. It means this is increase in internal energy. So this is how you can calculate increase in internal energy. In this case, kinetic energy of molecules will not change because it is just phase change. Liquid at 100 degrees Celsius is converted into water vapor at 100 degrees Celsius. But potential energy of molecules in this case will increase because internal energy has been increased. Internal energy is the sum of kinetic energy of molecules plus potential energy of molecules. In this case, kinetic energy remains constant because temperature remains constant, but in this case, potential energy of molecules increases because bonds are broken. So this is what you need to understand to answer this question. Our final answer is 7.9 times 10 to 5. This question has 2 marks. 1 mark you will get if you have written this one. So this is the B mark. You will get B mark. So in this case, you will say work done against atmosphere. In this case, water does work against atmosphere. So work done on water is negative. So you can write down water does work on atmosphere. Water does work on atmosphere. So work done by water is negative. So work done by water is negative. So work done by water is negative. If you write on this one, you will get 1 mark, and that is the mark. If you just write down this much, it should be fine. But still, you can write down water does work on atmosphere. So work done by water is negative. Does work on atmosphere. So work done by water is negative. Because work done on water is taken as positive. Because question is asking you to explain your reasoning. So it's better if you write down this one. And the second mark you will get if you have got the right answer. You will get the second mark. For part C, we need to use first law of thermodynamics to suggest with a reason how the specific latent heat of vaporization of water at a pressure greater than atmospheric pressure compares with its value at atmospheric pressure. So in this case, value of P has been increased. We can simply start this one with first law of thermodynamics. Delta U is equal to Q supplied. So Q supplied plus work done on water, But in this case, when liquid change into water vapor, volume is increasing. So work is done by water vapor. So we can rewrite this. We can write down Q supplied minus work done on water, because in this case work is done by water. So work done on water is negative. So we can write down work done on water. Work done on water is equal to work done by water but negative of that. So that's the reason we have here negative sign. Work done on water. So in this case work done on water is negative because liquid expands when it change into water vapor. So that's the reason we have negative sign here. So we have delta U here. Now we can write down here Q supplied minus P times delta V. So means work done is equal to P times delta V. In this case, value of P has been increased. We can also write down delta U here for the same change in internal energy and for the same change in volume. If P increase, it means work done on water increases. If work done on water increases, delta U is the same. So it means Q supplied also has to increase. So simply we can replace Q supplied. In this case, Q supplied is equal to M times L. M is the mass of the water. L is the specific latent heat of vaporization. Times we have P times delta V. As this quantity increase, it means this quantity also has to increase. But mass is constant. Mass of water vapor doesn't change in this case. So L has to increase in this case. So simply L increases. So this is one thing you need to understand. So in this case, L increases if P increases. So this is one thing you need to understand. L increases. Now we need to explain why L increases. So simply you can write on 1 point, work done on water increases, or you can say work done by water increases. So better you can replace this one with work done by water. Work done by water increases. Why work work done by water increases because work done is equal to P times delta V for the same change in volume. If P increases, it means work done increases. And the second point we can write down, for the same change in delta U, you can write down delta U is equal to Q supplied. Delta U is equal to Q supplied minus work done on water. So work done on water increases, so Q supplied has to increase. So the third point you can write down, Q supplied is equal to M times L. M is constant. If Q supplied increases, it means latent heat of vaporization has to increase. Or simply you can say latent heat of vaporization increases. So this is how you can answer this question using first law of thermodynamics. This question has 2 marks. If you have mentioned these points, you will get 2 marks. The first mark is M mark. Means if you have mentioned about work done by water increases because P increases, you will get 1 mark, and this is M mark. And the second mark you will get if you have used this reasoning and you have explained that Q increases and then you have mentioned L increases, you will get second mark, and that is answer mark. That's all for today's video, and if you have any questions about today's lesson or you have any questions from any other past papers, you can leave your questions in comments and I will be answering as soon as possible. See you in next video, and in next video we will also discuss another question from same paper. Bye for now. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from June 2022, paper 4, variant 2. In this question, we will discuss some very important points about simple harmonic motion. And this video will help you to improve your conceptual understanding of simple harmonic motion. Watch the video carefully and try to improve understanding of this topic. Let's study together. Let's improve together. For question number 4, part A, we need to state what is meant by resonance. Resonance is very interesting phenomenon. It has many applications in our everyday life, and also we can use this phenomenon in many ways for our own benefit. Let's try to understand this one with the help of simple pendulum. Simple pendulum simply means that we have a string and we attach one heavy mass at the end of the string. This setup means this simple pendulum has its own natural frequency. It has its own natural frequency. Natural frequency simply means that, imagine that we have this physical pendulum. This is an example of physical pendulum. If I displace this one and then let it go, it will oscillate with certain frequency. When it is oscillating freely, means there is no any external force is acting on this, then the frequency of this one is natural frequency, means it is oscillating at its own natural frequency. Now imagine that we apply force on this one. If the frequency of driving force is the same as natural frequency of this pendulum, its amplitude will go on increasing, and this phenomenon is called resonance. You can imagine that it is oscillating with this natural frequency. Now if I apply force on this one, it's with the same frequency as its natural frequency, its amplitude will go on increasing and increasing, and this phenomenon is called resonance. So in this case, simply we can write down, if natural frequency and driving frequency, they are the same, resonance will take place. So we can say resonance will take place. So we can say resonance, and response, system will respond in this case at maximum amplitude. So we can say maximum possible amplitude. So system responds at maximum amplitude. Response at maximum amplitude. Even in our body, in our chest, we have certain holes and water inside. Those holes, they have their own natural frequency. If we hear music with the same frequency as natural frequency of these holes in our chest, we feel kind of excitement. That is also an example of resonance. This is how you can state what is meant by resonance. Simply you need to mention a phenomenon in which a system responds at maximum amplitude to an external driving force. And the second point you need to write down, when the driving frequency is equal to the natural frequency of the driven system, resonance will take place. And this question has 2 marks. If you have written these 2 points, you will get 2 marks. The first mark you will get if you have written this first point, you will get 1 B mark, and the second mark you will get if you have written the second point, means the natural frequency is equal to driving frequency. You will get 2 marks. For part B, it is given to us figure 4.1 shows a heavy pendulum and a light pendulum, both suspended from the same piece of string. This string is secured at each end to fixed points. So we have fixed points here. We have heavy pendulum in this case, we have light pendulum, and they're attached with the same string. Both pendulums have the same natural frequency. The heavy pendulum is set oscillating perpendicular to the plane of the diagram. So simply imagine that this is the plane of the diagram, and this pendulum will oscillate like this, perpendicular to the plane of the diagram. So it will oscillate like this. As it oscillates, it causes the light pendulum to oscillate as well, because these 2 pendulums, they have the same natural frequency and they're attached with the same string. So if one start oscillating, other one will also start oscillating. For this question, it is also given to us figure 4.2 shows the variation with time t of the displacement of 2 pendulums for 3 oscillations. We have displacement on y-axis and we have time on x-axis. It is also given to us the variation with time of the displacement x of light pendulum is given by x is equal to 0.25 sine of 5.0 times pi times t, where x is in centimeters and time is in seconds. We need to calculate time period of oscillations. So simply you need to understand this equation in order to calculate time period. So I will be writing this one again. So it is given to us x as a function of time. This is equal to 0.25 sine of 5.0 pi times t. We need to compare this one with standard, or simply you can say journal equation. X is equal to x naught sine of omega t. Sine of omega t. Now from here you can compare x naught is equal to 0.25, mean this is the amplitude 0.25. It is given to us that x is in centimeters, so this is in centimeters. Now we can find out omega. So this one is omega. Omega in this case is equal to 5.0 pi, or simply we can say is equal to 5 pi. So we can write down here. We need to calculate time period. Omega is equal to 2 pi over time period. We need time period, so simply we can rearrange. This one will be equal to 2 pi divided by omega. Now if we plug in value of omega, we can solve this one for time period. Omega is equal to 5 pi. So we can cancel pi with pi, so we left with 2 divided by 5, and this is equal to 0.40 seconds. So the time period of this pendulum is 0.40 seconds up to 2sf. So this is our final answer. This question has 2 marks. The first mark you will get if you have written t is equal to 2 pi over omega, you will get 1 mark, and that is C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. This is how marks will be awarded for this question. So it's very important. Always you write down the equation before you sub values. Before you plug in values, always write down equation. If your calculation is wrong, but still you will get 1 mark just for writing equation for the question. So you have to be very systematic when you answer these problems. For the second part on figure 4.2, we need to label both of the axes with correct scales. Use the space below for any additional working that you need. For this question, we have already calculated for the light pendulum, time period is equal to 0.40 seconds and amplitude is equal to 0.25 0.25 centimeters. You can just read amplitude directly from here. Now we need to label this one. First of all, we will label x-axis. Time period is given, that is equal to 0.40 seconds. So here we can simply label this is 0.40 seconds. So halfway, this one has to be 0.20. And next one, you can label this one has to be 0.60, and this one has to be 0.80, and this one has to be equal to 1.0, and the last one will be 1.2. So this is how you can label x-axis. And for y-axis, amplitude is equal to 0.25. It means here we have 0.25, and 0.25 is equal to five small boxes. So we have 1, 2, 3, 4, 5. So 5 small boxes equal to 0.25 centimeters. So 10 small boxes will be equal to 0.5 centimeters. So this is 0.5, and this one will be 1.0. And here you can also label this is negative 0.5, and this will be negative 1.0. So this is how you can label. Main thing you need to understand, we have time period, we have amplitude. Then you can look at the scale and you can label this. Let me show you a clear picture of this. This is a clear picture, so you can see this one now. It's better to see. So this is how you need to label. So you can see the clear picture. This is how you need to label. If you label these both axes, you will get 2 marks. And this question has only 2 marks. If you have labeled x in a right way, you will get 1 B mark. If you have labeled y-axis in a right way, you will get another B mark. And this question has only 2 marks. For the last part, we need to determine the magnitude of the phase difference phi between the oscillations of the light and heavy pendulums. And also we need to give a unit with answer. So first thing, we need to understand how we can calculate phase difference. So we have 2 waves. Let's say this one is wave A and this one is wave B. Now we need to take 2 same points on these 2 waves. Let's say we take this point on wave B. So the same point on wave A will be this one. And we need to find the time difference between these 2. Time difference. So the time difference, I can say delta T between these 2 waves is equal to 0.10 seconds. So this is the time difference. This is time difference between these 2 waves. And the time period we have, that is equal to 0.40 seconds. Now we need to use ratio method and we can find the phase difference. We need to understand the ratio between time difference over time period is the same as ratio between phase difference and 2 pi. Now we need to find phase difference. So simply we can write down phase difference will be equal to delta T times 2 pi divided by time period. Delta T in this case is equal to 0.10 seconds, and here we have 2 pi, and this has to be divided by time period. These 2 waves, they have the same time period. Now if we solve this one, our answer will be 1.6 radian up to 2 SF. So this is up to 2 SF. You will get answer 1.5 something, but up to 2 SF you have to write down 1.6. So the magnitude of phase difference is 1.6 and the unit is radian. This question has 2 marks. The first mark you will get if you have written this equation. You will get 1 C mark. And the second mark you will get if you have got the right answer. And this one is answer mark. If you got right answer, you will get 2 marks. But if your answer is wrong, you have written this equation, you will still get 1 mark. We can also extend this one. This is also equal to, for the waves, path difference divided by lambda. Path difference by lambda. So you can extend this one. For waves, if path difference is given and lambda is given, you can also calculate phase difference. So very important equation for your ES level and also very important for A2 physics. So this is how we can answer. That's all for this question and also for this video. I'll see you in next video, and next video will be about May June 2022 paper 4 variant 2. We will discuss another question from the same paper in next video, and next video will be coming very soon. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very nice question on capacitance from May June 2022, paper 4, variant 2. In this lesson, we will talk about how to calculate combined capacitance of capacitors connected in series and also how to calculate combined capacitance of capacitors connected in parallel. We will also discuss how to calculate energy stored in a capacitor, and also we will discuss how to calculate discharging time for a capacitor. So these concepts are very important to understand this topic, and we will discuss all these concepts in today's lesson by solving past paper questions. Let's study together, let's improve together. For our question number 5, part A, we need to define capacitance of a parallel plate capacitor. And this question is very common in past papers. You need to understand how to define capacitance in a proper way. This is a typical type of question. You will see this question in many past papers. Let's try to define capacitance in a right way. First thing we need to understand, Q is equal to C times V. From here we can write down C is equal to Q over V. And Q is the charge on one plate. Actually, this charge is the net charge on one plate. So simply you can say charge on one plate. So very important, this point you have to mention in your answer. And V is the potential difference across plates. So this is the PD across plates, meaning the potential difference across plates. Now, one thing you also need to understand, C does not depend on Q, C does not depend on V. C depends on physical properties of capacitor. C is equal to K times epsilon naught A over T. C depends on area of the plate, C depends on dielectric constant, and C depends on separation between plates. D is the separation between plates. C does not depend on Q, C does not depend on V. It simply means that if you increase charge on the plates, V means the potential difference across plates will also increase. Mean if you increase net charge on one plate, potential difference between plates will also increase. And vice versa is also true. If you decrease Q, V will also decrease. Let me sketch parallel plate capacitor here so you can see how it looks like. So this is parallel plate capacitor, means simply we have two plates, and Q, let's say the net charge on this plate is plus Q and the net charge on this plate is minus Q. So this Q is the charge on one plate only, but the net charge negative Q is equal to positive Q. We simply separate charges in capacitor. So this is net charge on one plate, this is net charge on another plate, and V is the potential difference between these two plates. Simply you can draw your voltmeter here. So V is the potential difference between these two plates, and this is the separation. D is the separation between plates. We can label this one as D. And area of the plate, A is area of plate, area of one plate. So this is area of one plate. We are talking about parallel plate capacitor. So this is what you need to understand about capacitance. Now let me show you the answer, how you can write down the answer. This is how you can write down the answer. You can simply mention capacitance is equal to charge over potential difference, and charge is charge on one plate and potential is potential difference across the plates. This one has 1 mark, M mark. If you have written this charge over potential difference, you will get M mark. And the second, if you have defined what is charge, what is V, you will get the second mark, and second mark is answer mark. This is how marks will be awarded for this question. For part B, it is given to us two capacitors of capacitance C1 and C2 are connected in parallel to a power supply of electromotive force capital E as shown in figure 5.1. For part B, we need to show that combined capacitance CT of two capacitors is given by CT is equal to C1 plus C2. We also need to explain or reasoning, means we need to show or working, and it is also given to us. We can draw on figure 5.1 if we wish, but this part is optional. Now let's try to understand first of all what is the potential difference across C1 and C2. If we connect a voltmeter here, let's say we connect voltmeter V1 across capacitor C1. So the reading of this voltmeter will be equal to capital E, because it is just connected across terminals of power supply, and this power supply has no internal resistance. We are talking about ideal battery. And same if we connect a voltmeter across the second capacitor, let's say this voltmeter is V2 and this one is V1. So the reading on this voltmeter also will be equal to E. It simply means that the potential difference across these two capacitors is the same. Now let's try to understand how we can calculate charge on these two capacitors. Q is equal to CV. Let's say this is capacitor 1, so Q1 in this case simply will be equal to C1 times E, and Q2 in this case will be equal to C2 times E, because Q is equal to CV. Now we need to understand what is the total charge stored on these two capacitors. So we can write down total charge, Q total. Q total simply will be equal to Q1 plus Q2. Now we can sub these values, means we can replace Q1 with C1E, and we can replace Q2 with C2E, and we can also write down the total charge on these two capacitors. That one will be equal to C total times E. C total times E. Now in this case you can see E is common, so we can rewrite this. We can write down CTE. This one is equal to E times C1 plus C2. So E is common on both sides, simply we can cancel. So our final answer means the value of C total will be equal to C1 plus C2. So this is what we need to derive, and this is our final answer. If you have written this one, you will get, in this case, 3 marks. The first mark you will get if you have written the potential difference across each capacitor is equal to E, you will get 1 mark. That is 1 B mark. And the second B mark you will get if you have written this step. You will get second B mark. And third B mark you will get if you have got the right answer. So this one is third B mark if you have got this right answer. This is how marks will be awarded. So you need to understand, when capacitors are connected in parallel, imagine that we have these two capacitors. This is one capacitor, this is another capacitor. So simply if you join them together, so you will see this is resultant capacitor, and the total charge on this big capacitor is the sum of two individual capacitors. Means the charge has to be added in this case. So simply you have two small plates, you combine them, so you have one big plate. So in this case capacitance will increase, so you have to add capacitance. So that's the reason we have got the formula C1 plus C2. For part C, it is given to us two capacitors of capacitance 22 microfarads and 47 microfarads, and a resistor of resistance 2.7 mega ohms are connected into the circuit as shown in figure 5.2. It is also given to us the battery has an EMF of 12 volts. For part C1, we need to show that combined capacitance of two capacitors is 15 microfarads. Now, first of all, we need to understand, are these capacitors connected in series or are they connected in parallel? In this case, you can see these capacitors are connected end to end. So these two capacitors are connected in series. They are connected in series. So first thing we can write down, these two capacitors are connected in series. So simply you can draw these two capacitors, and these two capacitors are connected in series. Now the next thing we need to understand, if the capacitors are connected in series, how we can calculate the total capacitance? This is like resistors connected in parallel. So simply in this case we can write down 1 over CT has to be equal to 1 over C1 plus 1 over C2. So you can plug in values here. We have 1 over 22 microfarads. So we have 1 over 22 microfarads, and we have 1 over 47 microfarads. 47 microfarads. We need to add these two together. So here we can write down this one is the total capacitance. Now we just need to calculate value of CT. So we can rewrite this one. We can write down 1 over CT. And if we take LCM on right side, we can write down 22 times 47. So if we divide this one by 22, we will get 47. And if we divide this by 47, we will get 22. Now we can flip this. Then we can write down CT. CT will be equal to 22 times 47 divided by 22 plus 47. If we solve this one, our final answer will be 15. And this one is 15 microfarads because we are using units for capacitance, microfarads. And this is the final answer. And this is what we need to calculate. And this question has only 1 mark. If you have got the right answer, you will get 1 mark. For the second part, it is given to us the two-way switch S is initially at position X so that the capacitors are fully charged. We need to use the information in C1 to calculate the total energy stored in the two capacitors. So in this case, simply you need to understand these two capacitors. The total capacitance is equal to 15 microfarads. So simply we can replace these two capacitors with one single capacitor. So let me redraw the circuit. If you redraw this circuit, in this circuit, you can replace this with one capacitor. So we can simply redraw C total. So this is our C total. And the EMF of this power supply is given, that is equal to 12 volts. And this capacitor, total capacitance of this one is 15 microfarads. Now we need to calculate the total energy stored in this capacitor when this capacitor is fully charged. In order to calculate energy stored, total energy stored in this capacitor when this capacitor is fully charged, we can simply use 1/2 CV squared. Value of C we have, that is equal to 15 microfarads, and we have value of V, that is equal to 12 volts. Now simply we need to put these numbers in calculator and we can calculate E total. E total in this case will be equal to 1.1 times 10 to minus 3 joules. And this is our final answer up to 2 SF. Up to 2 SF, because this data has 2 SF. So we have to follow the least number of SF in given data. So our final answer is 1.1 times 10 to minus 3 joules. And this question has 2 marks. The first mark if you have written this formula, and the second mark is the answer mark. If you have got the right answer, you will get 2 marks. So this is how marks will be awarded. For the last part, it is given to us the two-way switch is now moved to position Y. Means we move this switch from X to Y now. So this is how our circuit is connected. If you look at this circuit now, you will see in this case there is no power supply. If there is no power supply and capacitor is charged, capacitor will start discharging. So in this case, our capacitor will discharge. For this question, we need to determine the time taken for the potential difference across 22 microfarad capacitor to become 6.0 volt. So we have to calculate time taken for this capacitor to discharge to 6.0 volts. So simply imagine that it has some initial voltage across, and then that voltage drops to 6.0 volts, and we need to calculate time taken. So this is what question is asking us. We need to calculate time taken. Let's say time taken is equal to small t. First of all, we need to calculate value of V naught, means the value of initial potential difference across this capacitor. But we have already discussed that the total capacitance of these two capacitors is equal to 15 microfarads. So simply we can write down this is equal to 15 microfarads. Now we need to understand when two capacitors, they are connected in series, they have same value of Q. Q is same. So we can say Q is same. It simply means that Q same means that the Q total This is equal to Q on 22 microfarad equal Q on 47 microfarad, because when capacitors are connected in series they have the same charge, and the charge on 22 and charge on 47 microfarad is equal to QT, total charge. Let's try to calculate Q total now. Q total simply will be equal to C total times the potential difference across these two capacitors. We have value of C total that was equal to 15 microfarads, and we have value of V across these two capacitors that is equal to 12. So this is how we can calculate Q total. Let's try to calculate potential difference across this 22 microfarad capacitor. So simply we can say V across 22 microfarad capacitor. We have already said initially it is equal to V naught. So this is value of initial potential difference across this capacitor, and that one will be equal to the Q total divided by the capacitance of 22 microfarad, means 22 times 10 to minus 6, and Q total is equal to Q1 as well. So simply we can plug in these values. We have 15 times 10 to negative 6 times 12, and this is divided by 22 times 10 to minus 6. If we solve this one, our final answer in this case will be equal to 8.2. So we will get value of potential difference across 22 microfarad capacitor, and this is the initial value of potential difference across 22 microfarad capacitor. For this question, we need to calculate the time taken for the voltage to drop from 8.2 to 6.0 across 22 microfarad capacitor. Now we have value of initial voltage and we have value of final voltage, so simply we can calculate time taken. We have to use V as a function of time. This is equal to V naught. This is the formula for discharging circuit, means for discharging capacitor, V naught e to the power of minus t over RC. Vt is the final voltage, that one is equal to 6.0 volts. This is given. V naught is the initial voltage, that is equal to 8.2 e to the power of minus t. This is what we need to calculate, and RC is the time constant. This is a little bit confusing. Maybe this will confuse you if you have not clear understanding of discharging capacitor. Let's try to understand how we can calculate tau, time constant. This is equal to RC. R is the resistance in the discharging circuit. In this case, resistance is equal to 2.7 times 10 to 6. Mean this one is our resistor in this discharging circuit. Now you need to consider the total capacitance of discharging circuit, not the capacitance of this 22 microfarad capacitor. So this C is 15, means the total capacitance 15 times 10 to minus 6. Now if you multiply this, 10 to 6, 10 to minus 6 will be cancelled. So 2.7 times 15, we will get this is equal to 40.2. So this is value of RC. R you can simply say this is over time constant. Now we can plug in these values. We have 6.0, that is equal to 8.2 times e to the power of minus t divided by 40.2. Now we can take natural log on both sides. Before we take natural log, we can further simplify. We can write down 6.0 divided by 8.2. This is equal to e to the power of minus t over 40.2. Now we can take natural log on both sides. We will get 6.0 divided by 8.2. On this side we will get minus t, because natural log of e is equal to 1. So this point you need to understand. Natural log of e is equal to 1. So we have minus t divided by 40.2. We need to find value of t, so we can write down minus t. In this case will be equal to natural log of 6.0 divided by 8.2, and we need to multiply this one with 40.2. If we solve this one, our answer will be about 12.55 and we can write down this one up to 2SF 13 seconds. We will get positive answer because when you will solve this one, your answer will be negative. So negative will be cancelled. So this is our final answer, and this is how you can answer this question. This question has 3 marks. The first mark you will get if you have got the right value of final voltage, right value of initial voltage across 22 microfarad capacitor. You will get 1 mark, and this is C mark. And second C mark you will get if you have used this formula. You will get second C mark. And the last mark is answer mark. If you got the right answer, you will get 3 marks for this question. I'll see you in next video with another question from May June 2022, paper 4, variant 2. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetism and magnetic fields from May June 2022, paper 4, variant 2. In this question, we will discuss forces between 2 wires. Means when 2 wires are placed like this, parallel to each other, how they exert forces on each other. Are those forces attractive forces or repulsive forces? And we will also discuss some other important points about electromagnetism and magnetic field in this lesson. Watch this video carefully and try to improve your conceptual understanding of these topics. Let's study together. Let's improve together. For question number 6, part A, we need to state 2 conditions that must be satisfied for a copper wire placed in a magnetic field to experience a magnetic force. Let's try to understand this one with the help of magnetic force equation. And this question is simply asking us if you place a wire in a magnetic field, when wire will experience a magnetic force. So simply we can understand this one with the help of magnetic force equation. FB means the magnetic force is equal to I times L times P times sine of theta. And theta is the angle between B and L. Now we need to understand if I is equal to 0, it simply means that there will be no force on the wire. And if sine of theta is equal to 0, then also there will be no force on the wire. Sine of theta, if this is equal to 0, it simply means that theta is equal to 0. So if theta equal to 0 or current equal to 0, there will be no magnetic force on the wire. And simply these 2 points we have to mention in our answer. Mean there must be current in the wire. We can say must current in the wire, and also wire has to be placed at non-zero angle. So simply you can say non-zero angle. Then wire will experience a force. So simply we can mention these 2 points and you will get 2 marks. So this is how you can write down your answer. First point you can say there must be a current in the wire, and the second point you can say wire must be at a non-zero angle to the magnetic field because theta is the angle between B and L. If you mention these points, you will get 2 marks. You will get 2 B marks. For part B, it is given to us a long air core solenoid is connected to a power supply so that solenoid creates a magnetic field. Figure 6.1 shows a cross section through the middle of the solenoid. So imagine that we have the solenoid like this, and we cut this solenoid from the middle, means from the center, and this is what we will see then. So these are the wires, so these are wires, so these are the wires. It is also given to us direction of the magnetic field at point W is indicated by the arrow. 3 other points are labeled X, Y, and Z. For part B1 on figure 6.1, we need to draw arrows to indicate direction of the magnetic field at each of the points X, Y, and Z. So first of all, in order to answer this question, we need to understand magnetic field around solenoid and magnetic field inside solenoid. Magnetic field inside solenoid is uniform. So this is the first thing you need to understand. B inside solenoid is uniform. So we can write down B inside solenoid is uniform. But B outside of solenoid is not uniform. As B inside solenoid is uniform, as you can see here, the lines, magnetic field lines inside the solenoid, these lines are at equal distance from each other. So the magnetic field has to be uniform. So it means magnetic field has the same magnitude and magnetic field has the same direction, because inside magnetic field has only one direction, and that is to the right. Means the same. You don't need to follow this. You need to follow this one. It is given to you. It is to the right. But this solenoid, magnetic field of this solenoid and magnetic field of given solenoid are the same. So this has magnetic field to the left. So at point X, magnetic field also has to be to the left. And the magnitude of magnetic field is same. So the length of arrow has to be the same and it has to be in the same direction. Now we need to understand magnetic field at point Z. At point Z, you can see if magnetic field lines are here, you can see these are pointing to the right. So you can draw arrow here. This arrow has to be to the right. And this magnetic field has to be weaker than magnetic field inside solenoid and also magnetic field at this point. Because here magnetic field lines are dense, it means magnetic field is stronger here as compared with this one. And at this point, magnetic field lines are at an angle of 45 degrees. So here simply you can draw the arrow pointing upwards at an angle of 45 degrees. But we also need to consider the length of the arrow. So this arrow has to be a bit smaller than the arrow at the center of the solenoid. So this one has to be a bit shorter, but it has to be longer than this one, because magnetic field here is the weakest, because lines are further away from each other. So this is all what you need to understand about magnetic field inside a solenoid and magnetic field around a solenoid. You have drawn these arrows in the right way, you will get 3 marks. And this question has 3 B marks. For the second part, we need to compare the magnitude of the flux density of the magnetic field at point X and at point Y. We have already discussed magnetic field at point X and at point W. Means at point X and at point W is almost same, is approximately same, because magnetic field inside solenoid is uniform. So simply we can say magnetic field at point X means the magnetic flux density. This is approximately equal to magnetic flux density at W. And for the second part, we need to compare at point Y and at point C. Means at this point and at this point. We have already discussed magnetic field at Y is stronger than magnetic field at Z. So simply we can say magnetic flux density at Y is greater than magnetic flux density at Z. So that's all what you need to write down. This question has 2 marks. So this mark is 1 B mark and this is second B mark. So this is another B mark. Let me show you the answer. This is how you can write down. So simply you can say in this case flux densities are approximately equal at point X and W, but at point Y flux density is greater than flux density at C. So this is how you can answer. For part C, it is given to us 2 long parallel current carrying wires are placed near to each other in a vacuum. We need to explain why these wires exert a magnetic force on each other. We can also draw a labor diagram if we wish. Means it is optional, not required. Let's try to start answering by sketching wires. Imagine that this is wire A and current in this wire A is to the right. We have another wire and current in this wire is also to the right. So simply we can write down this is current and this is wire B. Now we need to find out force on one wire due to an other wire. So we need to understand magnetic force FB is equal to ILB. In this case, this B you have to be clear. This is the external magnetic field, not due to the same wire. So I is current in the wire. If you are talking about force on wire A, so this is current in wire A. And B in this case will be the magnetic field of wire B. Let's try to find out force on wire B by wire A. So we can say by wire A. So we have to find out this force. In order to find force on wire B, we have to consider current in wire B, the length of wire B, and we need to consider magnetic field due to wire A. So this is BA. So these are the points you need to understand. Now let's try to find out magnetic field on this side of the wire, means at the lower side of wire A. In order to find magnetic field, imagine that this one is the wire. This is our wire A. In this wire A, current is flowing to the right. We need to find out direction of magnetic field at the lower side. So in this case, you have to place your hand. So you have to find magnetic field here because other wire is placed under this one. So you have to find magnetic field under wire A. So you have to place your right hand. Thumb has to be pointing towards direction of current. So current is to the right. So if you place your right hand, you will see under this wire, magnetic field is pointing into the page. But above this wire, magnetic field is pointing out of the page. But we are interested only under this wire. So we can draw magnetic field here. So magnetic field under this wire is into the page due to wire A. So we can also draw some crosses here. So magnetic field under this wire is into the page. Now you can see from here, this wire is inside magnetic field of wire A. So this wire B will experience a force. You can also understand if magnetic field will go from this point to this point, means away from the wire. You need to understand magnetic field is equal to B is equal to mu naught I over 2 pi r. As you go away from wire A, magnetic field has to get weaker. But we are not talking about these things. We're just talking about magnitude, means the force, why this will experience a force. We are not talking about the exact magnitude. If you need to calculate, we can also use this formula and we can calculate. If you want to use this formula, for example, in this case, you will get this is IB and here you have LB. So the B will be equal to mu naught IA divided by 2 pi r. And r is the distance between these two wires. So you can calculate magnitude of magnetic force as well. But in this case, we are only interested why this will experience a force. We don't need to calculate magnitude. Now you need to imagine this wire B is inside a magnetic field. That magnetic field is into the page. So let me draw in a different way so you can see the clear picture. So let me use different color. Now you need to understand we have the wire and the wire is inside external magnetic field. External magnetic field, I can write down the B. This external magnetic field is into the page. So I will write down EXT and this magnetic field is into the page. We have magnetic field that is into the page and current in the wire B. This current is to the right and we need to find out force on this wire. So we have to use Fleming left hand rule. So we have to use Fleming left hand rule and we can find out direction of force on wire B. So in this case we have magnetic field that is into the page, means this finger is pointing into the page and current is to the right. So the force on wire B is upwards, means this force will be attracted. So there will be attractive force on this wire upwards. So this is the force on B by A, and there will be force on wire A as well, action and reaction forces. So that will be pointing down, means these two wires, they will attract each other. So we can say force on A by B, that force will be pointing down. So this is what you need to understand. Simply you need to understand when this wire B is placed inside external magnetic field, and in this case external magnetic field is due to wire A. So the wire B will experience force by wire A, means these two wires, they will attract each other. In this case, if current is in the opposite direction, they will repel each other. Magnitude of this force on two wires will be the same, but direction will the opposite. So that's all what you need to understand. So let me show you the answer, how you can write down the answer. If you have any questions about this one, just leave your questions in comments. I will answer as soon as possible. So let me show you the answer. This is how you can write down the answer. And this question has 3 marks. If you have written these points, you will get 3 marks. Current in wire. Current in wire. In this case, we are talking about current in wire A creates magnetic field. And that is also true for B. B will also create its own magnetic field because current is flowing in wire B. Current in wire creates magnetic field around wire. Each wire sits in the magnetic field created by the other wire. We have discussed this point. If you need to find the force on wire B by A, you have to consider magnetic field of wire. For each wire, current is perpendicular. That's the reason we haven't used sine theta here, because sine of 90 degree is equal to 1. So that's the reason we haven't used sine theta here. They are perpendicular because current is here, magnetic field. So you can see current is this way, magnetic field is this. So the angle is 90 degrees. Current is perpendicular to the magnetic field due to the other wire. So experience a magnetic force. So this is how you can answer this question. I hope this is clear to you. If you have questions, just feel free to leave your question in comments and I will be answering as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on electromagnetic induction from May June 2022, paper 4, variant 2. I said this question is very important because in this lesson, we will discuss one key concept about electromagnetic induction. If you really want to understand electromagnetic induction, then this video is very useful for you. Let's study together. Let's improve together. For our question number 7, part A, we need to state Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction simply tells us that induced EMF is directly proportional to rate of change of magnetic flux linkage. Or simply, you can write down induced EMF in a conductor is directly proportional to rate of change of magnetic flux linkage, means d phi by dt. That's all what you need to write down for Faraday's law of electromagnetic induction. Let me show you how you can write down your answer. This is how you can write down your answer for this question. In your answer, you have to mention induced EMF is directly proportional to rate of. If you write down this, you will get 1 mark, and that is M mark. Means must mark. It has to be in your answer. Means you have to write down this one in your answer, then you will get M mark. If you will not get M mark, you will also not get the next mark. And the next mark is for writing change of magnetic flux linkage, and that is answer mark. If you have got M mark and you have written change of magnetic flux linkage, you will get answer mark. So this is how these 2 marks will be awarded. This question is a typical type of question. You will see this question in many past papers. So you need to understand how to state Faraday's law of electromagnetic induction. For part B, it is given to us 2 coils are wound on an iron bar as shown in figure 7.1. Coil 1 is connected to a potential difference V1 that gives rise to a magnetic field in the iron bar. A voltmeter measures the electromotive force V2 that is induced across coil 2. So here we have coil 2 and here we have voltmeter, and this voltmeter measures electromotive force across this coil. And this one is the iron bar. As you can see, this one is the iron bar. This rectangular shape is representing iron bar. Here we have coil 1 and this coil 1 is connected to potential difference V1. So this is a source of power supply. For this question, it is also given to us figure 7.2 shows the variation with time t of the magnetic flux density in iron bar. As you can see in figure 7.2, it is given to us how magnetic flux density is changing with time in iron bar. But we also need to understand coil 2, this is wound around iron bar. So the rate of change of magnetic flux in iron bar is the same as rate of change of flux in coil 2. In this case, we are talking about ideal case. Here is no magnetic flux leakage. So you have to be clear about this point. For this question on figure 7.3, we need to sketch the variation with time t of V2, means the EMF induced across terminals of coil 2 between time t is equal to 0 and time t is equal to 0.40 seconds. First of all, let's try to understand this one with the help of induced EMF. Induced EMF is equal to negative, or simply you can say minus d phi by dt, means rate of change of magnetic flux linkage. We can also write down this one minus dNBA, because magnetic flux linkage is equal to NBA if angle between area normal vector and B is equal to 0. So we can write down NBA because cosine of 0 is equal to 1, and this one is divided by dt. But in this case, number of turns are constant, so we can take this n out of this, and A is also constant because area of coil is constant. So simply we can write down this will be equal to dB by dt. So this is EMF. EMF is equal to this. Now from here we can find out dB by dt. This one is equal to gradient. So we can write down induced EMF is equal to minus NA times the gradient of figure 2 times gradient. And this is negative sign. This is very important. This negative sign is telling us when gradient is positive, EMF is negative. And when gradient is negative, EMF is positive. So this is very important point we need to understand. Now simply we need to look at gradient of this. As you can see, this gradient is positive. I will be writing M here. M is positive. Gradient is positive. So the EMF has to be negative. In this part, we can say this is part 1. And in the second part of this figure, you can see this is the second part. And this one, we can say this is the third part. In the second part, gradient is negative. So the EMF induced has to be positive. In third part, gradient is positive. So the EMF induced has to be negative. And second thing, we need to compare the gradient. So we need to compare gradient of part 1 with part 2 and with third part as well. So if you look at part A and if you look at part 3, these two, they have the same gradient. So we can say part 1 and third part, they have same gradient. If gradient is same, it means the magnitude of EMF induced also is the same. So we can say same EMF induced in part 1 and in third part. Now we need to compare these two with this one. Let's say this one is 0, so here we have 1. So here we will have minus 1. If you look at this point, this is equal to 0.15 and this one is 0.25. So we can calculate gradient of region 1, means the part 1. So we can say gradient M1. So I will be writing M1 here. So the gradient of this part will be equal to 1 divided by 0.15. So this is 0.15. Let's try to find out gradient of second part now. In order to find gradient of second part, we can write down the coordinates of this point and coordinates of this point. Coordinates of first point are comma 1 and the coordinates of this point are 0.25 comma minus 1. So we can calculate gradient of second part now in this second part. In this case, we have y2 that is equal to minus 1 minus 1 divided by, we have x2 that is 0.25 minus, we have 0.15. So in this case, we got this is minus 2 divided by 0.10. So we have gradient 1 and we have the second gradient. Now if we divide gradient 2 by gradient 1, we can find out how big is gradient 2 as compared with gradient 1. So simply we can do this one here. We can write down here M2 divided by M1. So in this case, we have M2 that is equal to minus 2 divided by 0.10 multiply with 0.15 divided by 1. Now, if we solve this one, we can find out how big is M2 as compared with M1. If we solve this one, we can find the ratio between M2 and M1. In this case, we have 2, so let me solve this one. 2 times 0.15, and this is divided by 0.10. So simply in this case, we will get our final answer, that is equal to 3. So this is our final answer. So it means that M2 is 3 times greater than M1. So we have to consider these points now, and we can sketch the graph. So let me show you how you can sketch the graph. So this is how you can sketch the graph. In this graph, you can see this gradient as compared with this one. This is 3 times greater than this. And when the gradient of this line is positive, this EMF has to be negative. We have already discussed here. And when gradient is negative, means the gradient of the second part is negative, so EMF has to be positive, and this EMF has to be 3 times of this one. So this is how you can see here. This one has 3 small boxes, 1 2 3, and this one has 9 small boxes. You can count from here, 1 2 3 4 5 6 7 8 9. So 3 times of this gradient, and this gradient of this part is positive, so the EMF has to be negative. So this one is negative, and this one has to be equal to this, so they have the same magnitude. So this is how you can scale this one. I hope this part is clear to you. If you have any questions, just leave in comments. For part C, it is given to us coil 2 in B is now replaced with a copper ring that rests loosely on top of coil 1. The supply to coil 1 is replaced with a cell and a switch, and switch is initially open as shown in figure 7.4. For part C1, it is given to us the switch is now closed. As it is closed, the copper ring is observed to jump upwards, means ring move upwards. We need to explain why this happens. So the first thing you need to understand, as ring go upwards, it means there is force on the ring that is acting upwards. So this is one key concept you need to understand. And this question is very nice question on EM induction. Let's try to understand this one step by step. If you have clear understanding of this question, it means you can answer a lot of questions, or simply I can say almost every question about EM induction. Means a lot of questions you can answer from past papers if you have clear understanding of this part of the question. Let's try to understand this one step by step. State 1. I will be writing here state 1. When switch is open, we can simply start when switch is open. Magnetic flux here in this ring is 0. So we can say in that case, magnetic flux in the ring is equal to 0. So simply we can say magnetic flux in the ring is equal to 0. So we can say magnetic flux in ring is equal to 0. The second state we can write down, as switch is closed, we can say as switch closed. As switch closed, magnetic flux in the ring will increase. Magnetic flux in the ring increases. As magnetic flux in the ring increases, according to Faraday's law, there is change in flux, and the ring will oppose that change according to Lenz's law. As external magnetic field means the external magnetic flux is increasing, so the ring will produce its own magnetic field to oppose that increase in magnetic flux. So simply we can write down the third stage. As magnetic flux changes, change of magnetic flux will cause induced EMF in the ring. Changing magnetic flux causes induced EMF in ring. Changing magnetic flux causes induced EMF. And induced EMF in the ring, this will cause induced current. So that will cause induced current in the ring. So first of all, EMF will be induced. Then this ring is a complete circle. So there will be induced current in the ring. And this induced current will flow in such a way that it will oppose the change in magnetic flux according to Lenz's law. So it will oppose oppose the magnetic flux. So how it can oppose? So this is very important point. Now you need to understand, in this case, the external magnetic field, we can say this is external magnetic field. As external magnetic field in this case is increasing, it increases from 0 to some value. So the flux of the ring due to induced current in the ring, we can write down flux due to induced current. So simply we can say flux due to induced current. So we can say I induced. That flux will oppose, that will be in the opposite direction. So you can see current will flow like this in this coil. And now you can use your right hand rule and you can find direction of magnetic field. In this case, magnetic field of this coil has north pole at the bottom and south pole at the top. So we can also simply sketch this one here. So this is magnetic field of the coil. So it has north pole at the bottom and it has south pole at the top. Now in this case, magnetic flux induced due to induced current, this one has to be in the opposite direction. So it will create its own magnetic field that will have south at the bottom and it will have north at the top. So it has south at the bottom. So simply I will redraw here so you can see what is going on. Current flow in this ring, it has its own magnetic field that has south pole at the bottom and it has north pole at the top. Now if you look at these two poles, means magnetic field of the coil and magnetic field induced in the copper ring have the same pole at the same point. So we have south pole here, we have south pole here. So these two same poles, they will repel each other. So it means there will be force on this ring in upward direction. So that's all what you need to understand. So due to interaction between these two magnetic fields, there is a force and that force is acting upwards because this force is repulsive force. So this one is repulsive force. So this is what is happening in this case. Let me show you the answer, how you can write down your answer. In order to write down the answer for this question, you can simply say changing current in coil causes changing magnetic field. Changing current in the coil because current will increase from 0 to maximum value. So that is changing current. So there will be changing magnetic field. So magnetic field will also increase from 0 to some maximum value. And changing magnetic flux causes induced EMF in the ring. So as we have discussed here, changing magnetic flux causes induced EMF in the ring. And induced EMF in the ring causes current in the ring. Means induced EMF causes induced current in the ring. And induced current has its own magnetic field. And that magnetic field is in opposite direction to external magnetic field, means magnetic field of coil 1. So as we have discussed, this one has north pole at the bottom, this one has south. So if we draw these two magnets together, you can see same poles, they repel each other. So there is a repulsive force, it will be pushed upwards. Field due to induced current in the ring interacts with the coil's field, means these two magnets, they interact with each other, magnetic fields, and cause upward force on the ring. Upwards force on the ring. So that's all what you need to write down for this question. If you write down your answer in this way, you will get 3 marks, means full marks for this part of the question. I hope this is clear to you, and this is the key concept about EM induction. For the second part, we need to suggest with a reason what would be the effect of repeating the procedure in C1 with terminals of the cell reversed. It simply means that everything else is the same. We simply reverse terminals of this cell. Now this side means this terminal is negative and this terminal is positive now. So in this case, current will flow this way when you close this switch. As soon as you will close the switch, magnetic flux in the coil will increase from 0 to maximum. And also magnetic flux in this ring will also increase from 0 to maximum. So as current flow in this coil, this current will produce its own magnetic field. According to electromagnetism, means electricity can produce magnetic field. And that magnetic field field, direction of that magnetic field you can find simply using right hand grip rule. So in this case, you have to use your right hand and you need to curl your finger in direction of current. So the thumb will give you direction of magnetic field, mean it will give you direction of north pole. So in this case, thumb is pointing up, so the magnetic field induced here, that magnetic field will have north pole at the top and south pole at the bottom. Now we need to understand magnetic field in the ring. So current will flow in the ring because ring is a complete circle. EMF will be induced and EMF will cause current in the ring. And that current will produce its own magnetic field. Mean current will flow in such a way, according to Lenz's law, that it will oppose the change in magnetic flux. So it will produce its own magnetic field, in this case in opposite direction, because in this case external magnetic field is increasing. If external magnetic field is increasing, B induced has to be in opposite direction. So this is the key concept you need to understand. These two fields have to be in opposite direction. So we can use different color and we can draw the magnetic field, or simply we can say in this case magnet induced due to induced current. They have to be in the opposite direction. You can see this magnet, it has N at the top, so this one will have S at the top, mean opposite. Then this one has S at the bottom, so this one will have N at the bottom. So in this case, you can see again they will repel each other because we have same poles here. So these two same poles, they will repel each other, means the like poles they repel. So again in this case, this ring will experience upward force. So upward force means in upward direction. But you also need to understand, when you open the switch, in this case force will be repulsive. But vice versa is true when you open the switch, because magnetic field here will decrease. So there will be attractive force on the ring. So switch open, attractive force. They can ask you next time about this. When you open the switch, what will happen? So there will be attractive force, so the ring will be attracted downward. So there will be attractive force. They can also ask you in the exam, if this switch is on for a long time, it is closed for a long time, is there any force on the ring or not? So we can say closed for a long time. If the switch closed for a long time, then what will happen? So is there any force on the ring or not? No force, because there is no change in magnetic flux. So there will be no force. So the ring will just stay there. So these things you need to understand about this type of questions. I hope this is clear to you. Let me show you the answer. In order to write down the answer for this question, simply you can say both magnetic fields, direction is reverse. So still there is upward force on the ring. And that's all what you need to understand. I hope this question is very clear to you. If you have any questions, you can leave your questions or doubts in comments. That's all for today's video. See you in next video. And next video will be coming very soon. And in next video, we will also discuss questions from May June 2022 paper 4 variant 2. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on quantum physics from May June 2022 paper 4 variant 2. In this question, we will talk about particulate nature of electromagnetic radiation, or simply we can say particle nature of electromagnetic radiation. We will also talk about wave nature of matter, and we will discuss the evidence for particle nature of EM radiations and wave nature of matter. Then we will talk about de Broglie wavelength, means how we can calculate wavelength of moving alpha particle. Then we will also sketch the graph between wavelength and momentum of a particle. At the end of this lesson, we will also talk about when we pass through a door, why we don't diffract. So we will discuss some interesting point about quantum physics in today's lesson. For question number 8, part A, we need to state one piece of experimental evidence evidence for the particulate nature of electromagnetic radiation. If we look at photoelectric effect is evidence for the particle nature of electromagnetic radiation. Let's try to understand a little bit about photoelectric effect. Imagine that this one is a piece of metal and EM radiations are reaching this metal surface, or simply we can say we shine light on this metal, and we will observe in this case if the energy of the photon of these electromagnetic radiations is greater than work function of the metal. In this case, photoelectrons will be emitted from this metal, and this emission of photoelectrons from the metal only can be explained if we use particle nature of EM radiation. This cannot be explained based on wave nature of EM radiation. So the evidence for particulate nature of electromagnetic radiation is photoelectric effect. So simply for the answer of this question, we can write down photoelectric effect. So photoelectric effect. And this question has only 1 mark. If you have written photoelectric effect, you will get 1 mark. And this is B mark. For the second part, we also need to state one piece of experimental evidence for wave nature of matter. And experimental evidence for wave nature of matter is electron diffraction. Electron diffraction simply means that when we pass electrons, mean fast moving electrons, when we pass them through graphite crystal, they spread out, and this spreading out of electrons can only be explained if electrons behave as wave. So this shows us wave nature of electrons. So the experimental evidence, simply you can write down electron diffraction. Electron diffraction actually takes place due to the size of atomic spacing. If the size of atomic spacing and wavelength of moving electron almost same, then we will observe significant diffraction. So simply you can say electron diffraction, and this question has only 1 mark, that is B mark. For part B1, we need to calculate the de Broglie wavelength of an alpha particle moving at a speed of 6.2 times 10 to 7 meters per second. And de Broglie wavelength is equal to Planck's constant divided by momentum of moving particle. Or simply we can say this is equal to h divided by m times v. M is the mass of particle, v is the speed of particle. In this case, our particle is alpha particle, and the mass of alpha particle is equal to 4 times u. Mean is equal to 4u, and 1u is equal to 1.66 times 10 to negative 27 kgs. So simply we need to plug in values now, and we can find out value of lambda. Planck's constant is equal to 6.63 times 10 to negative 34 divided by mass of alpha particle 4 times 1.66 times 10 to negative 27 kgs multiplied with speed of alpha particle, that is equal to 6.2 times 10 to 7 meters per second. If we simply solve this one, our final answer will be equal to 1.6 times 10 to minus 15, or simply you can say 10 to negative 15 meters. So this is value of lambda. So simply you have to use the formula and you can calculate value of lambda. So our final answer up to 2SF is 1.6 times 10 to negative 15 meters. This question has 3 marks. The first mark you will get if you have written this formula, and this is C mark. And the second mark you will get if you have calculated value of momentum of alpha particle. Mean if you have entered these values right, you will get another C mark. So this is the second mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks for this question. For the second part, it is given to us the speed v of the alpha particle in B1 is gradually reduced to 0. On figure 8.1, we need to sketch the variation with v of lambda. We have already discussed in this case that lambda is equal to h over over m times v. But in this case, h is constant and mass of particle is also constant. So simply we can replace these two quantities with one constant. So we can say lambda is equal to constant times 1 over v. From here we can write down lambda is inversely proportional to speed of the particle. Or you can say lambda times v is equal to h over m, and this is equal to constant. From here we can find out shape of the graph has to be hyperbola. Means when one quantity is increasing, other one has to decrease, and vice versa is also true. So this is how you can sketch the shape of the graph. So the shape of the graph has to be somewhat like this. So let me draw in a proper way so you can get better idea about this. This is how you can draw in a proper way. So this is shape of this graph, means this is hyperbola. And property of this graph is if you take any point on this curve, for example, if I take this point and I take another point, the product of lambda 1 times v1, it has to be equal to h over m. And at this point, lambda 2 times v2 also has to be equal to h over m, meaning it has to be equal to constant. So it has to stay constant. Then these two quantities are inversely proportional. For part C, we need to suggest an explanation for why people are not observed to diffract when they walk through a doorway. Let's try to understand this point with the help of sound waves. When sound waves they pass through a door, they diffract because we can hear someone talking inside room, even if we are not standing right in front of the door. It simply tells us that sound waves diffract when they pass through a doorway. But people, they do not diffract when they walk through a doorway. So we need to explain reason behind that. Let's try to understand this one with the help of de Broglie wavelength. Matter, you need to understand, also have wave properties. So let's try to find out our wavelength when we walk through a doorway. So we can calculate de Broglie wavelength. Means we can calculate lambda. Lambda is equal to h over m times v. In this case, h is equal to 6.63 times 10 to negative 34. Let's say the mass of a person is 70 kilogram and person is running through the door. So the maximum speed can be 10 meters per second. Now if we solve this one, we can calculate value of lambda. Lambda in this case will be equal to 9.4 times 10 to negative 37 meters. So this is value of de Broglie wavelength. Now let's try to imagine how wide a door can be. Means the gap of the door, or simply you can say width of the door. So we can write down width of the door. And width of the doorway can be about 1 meter. It can be plus minus greater or smaller. So for simplicity, we will say about 1 meter. Now if we compare lambda with the width of the doorway, you can see in this case lambda is much smaller than the width of the door. So in this case, simply we can say lambda is negligible. So in this case, we will not observe diffraction, because for significant diffraction to be observed, size of the door, means the width of the door, has to be comparable with wavelength of a person. But in this case, lambda is negligible. So that's reason we don't observe people when they walk through the door, they diffract. So people don't diffract when they walk through a doorway because the lambda is negligible as compared with width of the door. So that is the reason behind. And this question has only 1 mark. If you write down this point, you will get 1 mark. Let me show you the answer, how you can write down your answer. In your answer, simply you can say de Broglie wavelength is negligible compared with width of the doorway. And this question has only 1 mark, B mark. If you have written this one, you will get this mark. That's all for this question. And this is the first question from Module 2022, paper 4.2. And rest of the questions I will be uploading as soon as possible. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on astronomy and cosmology from May June 2022, paper 4, variant 2. In this question, we will talk about Big Bang. We will discuss about Hubble's law, and we will also talk about redshift. And these are three main concepts from astronomy and cosmology. Let's study together. Let's improve together. For our question number 9, part A1, we need to state Hubble's law. Very common question: what is Hubble's law? Let's try to understand what is Hubble's law. Hubble's law simply tells us the relationship between speed and the distance of galaxies. So now you need to understand what exactly speed is. Speed is the speed of recession of galaxies. So v is the speed of recession of galaxies. So simply we can say this is speed of recession, and d is the distance of galaxy away from observer. So this one is distance of galaxy away from observer. So you need to understand how to state Hubble's law in a proper way. So this is distance of galaxy away from observer. Away from observer. And these two quantities, they are directly proportional. Away from observer. It simply means that if d is greater, means the galaxy is far away from observer, it means that galaxy is moving faster as compared with galaxy that is nearby to observer. So as distance increases, speed also increases. Means the recessional speed increases. So the distant galaxies, they are moving faster than nearby galaxies. We can also write down this one in equation form. We can write down v is equal to h naught times d. Let's try to understand what is h naught. H naught is a constant, and this is called Hubble's constant, or simply you can say Hubble constant. We can also call this one rate of expansion of the universe. Rate of expansion means h naught is also rate of expansion of the universe. So simply you can write down rate of expansion of the universe. And we can use h naught, and we can also determine age of universe. So if we need to determine age of universe, we can use h naught and we can determine age of universe. Simply we need to take reciprocal of h naught. According to Hubble constant calculations, age of universe is about 14 billion years. Means 14 times 10 to 9 years. This is just approximate value, not exact value. Now let's try to understand Hubble's law with the help of this graph. You can see on y-axis we have recessional velocity, and on x-axis we have distance. If you look at these distant galaxies, let's say this galaxy, you can see this galaxy is distant galaxy, mean is further away from us. It has greater value of distance, and it has also higher value of speed. So simply you can see more distant galaxies, they are moving faster, means their speed is faster. They're moving at higher speed away from us. If you look at closer galaxies, means let's say this galaxy, its distance is smaller and its speed is also lower. So closer galaxies, their speed is slower, mean they have slower velocity. And that's all what you need to understand about Hubble's law. Let me show you how you can write down a proper answer. This is how you can write down your answer for this question. So in your answer, you have to mention these parts. In your answer, you have to mention that speed is directly proportional to distance, and this question has 1 mark, and that mark is M mark, mean it has to be in your answer. And the second mark is answer mark. If you have stated what is the speed and what is the distance, you will get the second mark, and second mark is answer mark. So you have to mention speed is directly proportional to distance, you will get 1 M mark. And then if you have explained what is speed and what is distance, you will get second mark, and second mark is A mark. For the second part, we need to explain how cosmologists use observations of emission spectra from stars in distant galaxies to determine that universe is expanding? Very nice question. So simply question is asking us, how do we know that universe is expanding? By studying spectra from different stars. If you look at these two spectra, you can see we have one spectrum from our sun. Actually, this is absorption spectrum, and we have another absorption spectrum from another star from another galaxy. If you look at these two spectra, you can see they have the same lines, or you can say same number of lines, but only difference between these two is in the second spectrum the lines are shifted towards red end of spectrum, red end of visible spectrum. So you see in our sun we see this line here, but in another star we see this line has been shifted by a certain amount, means it has been shifted towards red end of visible spectrum, or simply you can say in this case wavelength has increased. So lambda of spectral lines have been increased. From here, if the lambda has increased, simply we call this is redshift, and redshift tells us that distant stars, they are moving away from us. So they are moving away from us. So redshift simply tells us moving away from observer, or we can say moving away from our planet. So this is all what you need to write down for this question. So let me show you the answer, how you can write down your answer for this question. This is how you can write down your answer. First thing you can mention is wavelengths of spectral lines are greater than known values. Redshift shows stars in distant galaxies are moving away from us. So this question has 2 marks. The first mark you will get if you have written first point, and that one is B mark. You will get 1 B mark, and the second B mark you will get for the second point. So this is an other B mark. For part B, we need to explain how Hubble's law and the idea of the expanding universe lead to the Big Bang theory of the origin of the universe. In Hubble's law, we have already discussed distant galaxies are moving away from us and they're moving at higher speeds, and closer galaxies, they are moving away but they're moving at slow speeds. But if we imagine in the past, if we go back in the past, we can imagine a point where all matter must have been close together, and that is called Big Bang theory. Let's try to understand this one with the help of this figure. Now you can see we have these different galaxies, they're moving away from each other, means they're moving away from each other. But if we go back in time, if we go in the past, we can see these galaxies are closer together. But if we go even further back in time, we can see they're even closer together. So we can imagine a point where all the matter must have been close together. That is called Big Bang, and this is representing Big Bang theory. Mean as time is passing, galaxies are moving further away from each other. So this is, we can imagine at time t is equal to 0, then you can say this is time t1 and this is after time t2, and this is what is happening after time t3. So in this case t3 is greater than t2 and t2 is greater than t1 and this is greater than t0. So this is what we call is Big Bang. Big Bang tells us about origin of the universe. Let's try to write down our answer for this question. This is how you can write down your answer. You have to mention these points in your answer. First point, you can write down all parts of the universe moving away from each other. You will get 1 B mark, and second B mark you will get if you have written more distant objects are moving faster. You will get second B mark, and the third B mark you will get if you have written matter must have been close together in the past. You will get third mark. This is how marks will be awarded. This video is about Astronomy and Cosmology from June 2022 paper 4.2. And the next video also will be from the same paper, and next video will be coming very soon. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on nuclear physics from June 2022, Paper 4, Variant 2. In this lesson, we will discuss some important points about nuclear physics. Especially, we will discuss how to sketch different types of graphs. We will discuss how to sketch number of nuclei against time and how to sketch activity against number of nuclei. We will discuss these two types of graphs in detail so you can have clear understanding of these graphs. Let's study together. Let's improve together. For question number 10, part A, we need to state what is meant by radioactive decay. Radioactive decay is simply the emission of ionizing radiations, or you can say nuclear radiations from unstable nucleus. So this is how you can define radioactive decay. Let's try to understand this one with one simple example. Imagine that we have unstable nucleus, means this one is unstable nucleus, and this nucleus will try to be stable. For this nucleus to be stable, this has to emit nuclear radiations. Let's say this one is alpha emitter, so this will emit alpha particles to be stable. And when this will emit alpha particle, this will also emit gamma radiations, because gamma radiations are emitted in alpha decay and also emitted in beta decay. Most of the time in questions they will ask you where the extra energy has gone. So simply you can say it has been emitted in form of gamma radiations. In any nuclear reaction there are emissions of gamma radiations. So in this case this nucleus will also emit gamma radiations, and this is called radioactive decay. Means the spontaneous emission of nuclear radiations from this unstable nucleus is called radioactive decay. Let me show you the answer, how you can write down the answer for this question. This is how you can write down your answer. This question has 2 marks. You will get the first mark if you have written spontaneous emission of ionizing radiations. You will get 1 mark, and that one is B mark. And the second B mark you will get if you have written unstable nucleus. You will get second B mark. This is how marks will be awarded. It is given to us a radioactive sample consists of an isotope X of half-life T that decays to form a stable product. Only X and stable product are present in the sample. At time t is equal to 0, the sample has an activity of A0 and contains N0 nuclei of X. On figure 10.1, we need to sketch the variation with time t of the number N of nuclei of X present in the sample. Your line should extend from time t is equal to 0 to t is equal to 3 capital T. They're saying line. It doesn't mean you just need to sketch the line. It means you need to sketch the graph. First of all, let's try to understand how this nucleus X will decay. Initially, nucleus X has n number of nuclei. After one half-life, there will be n0 by 2 nuclei. And then after another half-life, this will be equal to n0 by 4. And after again another half-life, number of nuclei remaining in the sample means number of nuclei of X will be equal to n0 by 8. We can also write down in decimal form. So here we will have 0.50 n0 number of nuclei of X, and then we will have 0.25 n0 number of nuclei of X. And then finally, after 3 half-lives, we will have 0.125 n0. So these are the number of nuclei of X after one half-life. So this is after 1t, and this one will be after 2t, and this one will be after 3t. So this one is after 1t, and this one is after 2t, and this one is after 3t. Now simply we need to sketch this one. First of all, we have n0, and after one half-life, mean at time capital T, we have 0.50 n0, and then after 2 half-lives, we have 0.25, and then after 3 half-lives, we have 0.125, mean half of that. So simply in this case, you can count these small boxes. We have 1, 2, 3, 4, 5. So here, so this is the the number of nuclei remaining after 3 half-lives. Now simply we need to sketch, so you can draw a curve, so you need to connect these points. So this is how you can draw the curve. This is how you can sketch the curve. Not very good looking. Let me do this one again so you can see what's going on. So let me sketch this again. So simply you have to sketch like this. Yes, this one is better one. So this is how you need to sketch. If you sketch this one, you will get 3 marks for this question. So simply very typical type of graph you need to sketch between number of nuclei and time. I hope this one is clear to you. So here we are talking about number of nuclei of X remaining. So after 1 half-life, we have number of nuclei remaining 0.5 naught, and after 2 half-lives, we have number of nuclei of X remaining 0.25, and after 3 half-lives, we have 0.125. So this is 0.125 and naught. For the second part on figure 10.2, we need to sketch the variation with n of the activity A of the sample for values of n between n is equal to 0 and n is equal to n naught. So first of all, we need to understand how these two quantities are linked together. Means, is there any formula which link these two quantities together? We have one formula for activity and number of nuclei remaining in the sample. A is equal to lambda times n. In this case, you can compare this one with straight line equation y is equal to mx. So in this case, gradient will be equal to lambda, and lambda is constant. So lambda is constant. So the gradient of the line has to be constant and it has to be positive gradient. So it simply means that we have initially n number of nuclei, so the activity is this. And when number of nuclei become half, activity also become half. And when we have no number of nuclei, activity is equal to 0. Now simply we need to connect these points together. So simply we can draw a straight line connecting these points. So this is how you need to sketch the graph. And this question has 2 marks. If you have sketched this line, you will get 2 marks. For part C, we need to state the name of the quantity represented by the gradient of line in figure 10.1 and also in figure 10.2. This is figure 10.1. So simply we can write this is figure 10.1 and this one is figure 10.2. If you look at gradient of this one, if you need to find gradient at any point for this curve, gradient simply will be equal to delta n by delta t. And delta n by delta t means the number of decays per second. That is equal to activity. So the gradient of figure 10.1 simply is equal to activity. So we can write down this is equal to it. Let's say if you need to find the gradient at this point, so you will draw the tangent line and you need to find the change in y divided by change in t. So the change in y, this is delta n, and the change in time, this is delta t. So simply it is equal to delta n by delta t, number of decays per second, and number of decays per second is activity. And for the second figure, we have already discussed that A is equal to lambda times n. So if we compare this one with straight line equation, m means the gradient. This is simply equal to lambda. M here is the gradient. Lambda is decay constant. So the gradient of this line, we can simply say, is equal to decay constant, is representing decay constant. That's all what you need to write down. And this question has 2 marks. If you have written activity here, you will get 1 B mark. And if you have written decay constant here, you will get 2nd B mark. For the last part, we need to calculate the fraction n over n naught at time t is equal to 1.70 capital T. And capital T here is representing 1 half-life. And this one we need to calculate for the sample in P. And this is the graph for the sample in P. We need to calculate fraction. So simply we will start from radioactive decay equation. N is equal to n naught e to the power of minus lambda times t. We need to calculate fraction, so we can divide by n naught on both sides. Dividing by n naught on both sides, we will get n over n naught. And this is equal to e to the power of minus lambda t. But value of lambda is not given to us. But we understand lambda is equal to ln 2 over half-life over 1 half-life, t 1 by 2, 1 half-life. And 1 half-life in this case is equal to capital T. So now we can plug in value of lambda here and we can simplify. So we can rewrite this one, n over n naught. This is equal to e to the power of negative lambda. So we can replace lambda with ln 2 divided by capital T, 1 half-life. And we need to multiply this one with given time. That is equal to 1.70 times t. In this case, we can cancel this t with this t. So we simply left with e to the power of negative times we have ln 2. We have to multiply this one with 1.70. And then if we simplify, we can get the answer. So let me show you how you can use calculator and you can calculate value of n over n naught. You can press E on your calculator and then you can use minus sign and then you can multiply with ln of 2 multiplied by 1.70. If you multiply this, you have to close this bracket and you will get your final answer. So final answer in this case is equal to 0.307. So up to 2SF we can write down 0.31. So this is our final answer for this question, 0.31. This question has 2 marks. The first mark you will get if you have written this step, means you have written n over n naught is equal to this one. You will get 1 mark and that is C mark. And the second mark you will get if you have got right value of n over n naught, mean if your answer is correct. So this is how these 2 marks will be awarded.